standing on a dust particle. Somewhere between the core of an atom and the edge of the observable universe, we exist. Not especially large, nor especially powerful. A species capable of great intelligence and great confusion. This is a story about size and about how incredibly, mind-bendingly small we really are. We'll begin here with you. Humans scale the illusion of being big. We walk upright, we stretch our arms, we build towers. It's easy to feel large, but the truth is, we only look big to ourselves. A human is roughly 1.7 meters tall. The world around us, our rooms, streets, cars, is built to fit that scale. Our perception of normal is rooted in that. But compare it to a blue whale, 30 meters, Mount Everest, 8,848 meters, Earth's circumference, 40,075 kilometers, even on our own planet. We are specks. The microscale, the invisible empire. Dive inward. A red blood cell is about 7 micrometers wide, just 7/10 of a meter wide. A strand of DNA, just 2 nanometers across. And the atoms that make up your body, they're mostly empty space. If a hydrogen atom were the size of a football stadium, its nucleus would be a grain of rice at the center. Everything else is nothing. Zoom in further. Proteins fold themselves into complex machines only a few nanometers wide. Viruses are 20 to 300 nanometers. Ribosomes, your body's protein factories, are 20 nm. The electron cloud that surrounds an atom, a probabilistic blur. Go smaller. Proton radius, 84 femtometers. Planck length, 1.6 x 1035 meters, the smallest possible unit of space, as far as we know. It's not just that we are small. We are made of things so small, they defy intuition. Your body is a galaxy of particles obeying quantum laws that we still barely understand. The human body as a cosmic city. Your body contains 37 trillion cells, 10x more microbial cells, 100,000 kilometers of blood vessels. Every cell is a bustling metropolis. DNA strands uncoil and replicate. Proteins are assembled. Mitochondria power the entire thing like tiny generators. Ribosomes function like automated factories. Neurons pass signals as fast as 120 meters per second. Zooming into the brain. You have roughly 86 billion neurons. Each makes thousands of connections called synapses. Total synapses, 100 trillion. As many as stars in a galaxy. Inside you, systems more complex than cities are operating silently. And they all run on molecules smaller than the wavelength of light. From trees to planet sizes that make us blink. Now zoom out. Consider scale on Earth. A redwood tree, up to 115 meters. Boeing 747 to 70 meters. Burj Khalifa, 828 meters. Cities from above resemble microchips. Cars look like cells. Roads like blood vessels. Planet Earth. Diameter, 12,742 km. Surface area, 510 million km. Mass, 5.971020 GG. Population, 8 billion tiny humans. From space, Earth is a pale blue dot. Clouds swirl. Lights flicker. But life is invisible at this range. Planets, stars, and the impossible scale of the solar system. Our sun is massive. Diameter, 1.4 million kilometers. Volume? can fit 1.3 million Earths. Mass: 333,000 times Earth's surface temperature. 500 C, but it's just one of over 100 billion stars. Distances in the solar system. Moon: 384,400 km. Mars: 225 million km. Jupiter: 778 million km. Pluto: 59 billion km. Voyager 1, launched in 1977, is now over 23 billion kilometers away. Still moving, still sending, and yet it hasn't even left the solar system's influence entirely. The galaxy isn't even trying to be comforting. The Milky Way, 100,000 light-years across, contains between 100 and 400 billion stars. Our Sun is 25,000 light-years from the galactic center. We orbit the galaxy once every 230 million years. It's shaped like a disk, but with arms like a spinning pinwheel. Every dot in the night sky is part of it, but most of it we'll never see with the naked eye. We live in a spiral arm, a quiet suburb of an ancient city of stars. Cosmic web, a universe made of islands. Galaxies cluster together. The local group, 50 galaxies, Virgo cluster. Thousands of galaxies, Laniakea supercluster. Over 100,000 galaxies. These clusters are strung together into filaments. Between them, voids hundreds of millions of light-years across. The structure resembles neurons. The universe itself has a kind of cosmic brain, with galaxies for nodes. The observable edge. The observable universe is a sphere. Radius: 46.5 billion light-years. Diameter: 93 billion light-years. That's how far light has traveled since the Big Bang. We don't know what's beyond it. Maybe it loops. Maybe it doesn't. We can only see what light has had time to reach us. So even with our best telescopes, most of the universe is still hidden. Fractals and the pattern of existence. Nature copies herself. Trees branch like lungs, rivers meander like veins, galaxies spiral like storms. From Romanesco broccoli to hurricane patterns to neuron structure repeats. The universe is built on self-similarity. Maybe this is more than coincidence. Maybe the math of nature is universal. We are patterns of smaller patterns. Nested systems. Self-aware fractals. You, again in perspective. So where does that leave you? You are 70% water, made of atoms forged in stars, living on a tiny rock orbiting a mediocre star. And yet, you can think, you can imagine the size of a galaxy, you can measure it, question it, wonder at it. You are small, but aware, and in this cosmic vastness, that may be the rarest thing of all. What if the universe is conscious? A question as old as thought. For as long as humans have looked up at the stars, we have wondered not only what the universe is, but what it might know. Could the cosmos be more than just a stage on which the drama of life unfolds? Could it be the author as well? Could the universe itself possess a form of consciousness? This idea, once relegated to philosophy, mysticism, or science fiction, is increasingly discussed at the edges of modern science. Physicists, neuroscientists, cosmologists, and philosophers are asking, if consciousness emerges from complex systems like brains, could a sufficiently complex universe also be conscious? And if so, what would that even mean? In this documentary, we will explore this breathtaking concept from multiple perspectives: scientific, philosophical, and spiritual. We'll dive into quantum mechanics, panpsychism, cosmology, and theories of information to ask one of the most mind-bending questions imaginable. What if the universe is not just aware of us, but is us? What is consciousness? Before we can ask whether the universe is conscious, we must first understand what consciousness is. Despite centuries of thought, science has yet to provide a universally accepted definition of consciousness. Is it the ability to perceive? To experience? To make decisions? Is it a binary property, or does it exist on a spectrum? Most neuroscientists agree that consciousness involves subjective experience, what it's like to be something. But how that experience arises from matter is one of the deepest mysteries in science. The so-called hard problem of consciousness, coined by philosopher David Chalmers. From neurons firing in a brain to the glow of awareness behind your eyes, something astonishing happens in living minds. But where does it come from? Is it an emergent property of complexity, or is it a fundamental feature of reality? This is where the conversation gets truly cosmic. The rise of panpsychism. One of the most radical and surprisingly popular ideas in recent years is panpsychism, the belief that consciousness is a fundamental and ubiquitous aspect of the universe. According to panpsychism, even elementary particles like electrons may possess proto-consciousness, rudimentary forms of awareness that, when combined in complex systems, give rise to higher forms of consciousness, like our own. Think of it this way: instead of consciousness emerging from dead matter, perhaps matter itself has always had a seed of consciousness within it. Just as atoms combine to form molecules, maybe mind combines to form higher minds. This doesn't mean that rocks or spoons are thinking, but it suggests that the fabric of reality is more like a spectrum of awareness. Panpsychism has been seriously discussed by philosophers like Galen Strawson and even physicists like Roger Penrose. And it opens a door to an even wilder idea. What if the entire universe is a conscious whole? Quantum mechanics and the observer effect. Quantum physics has long been the realm of mystery and paradox, and consciousness seems to sit right at its center. In quantum mechanics, particles exist in superposition's multiple states at once until they are measured. Only then do they collapse into a single state. This is called the observer effect. But what counts as an observer? Does it require a conscious mind, or can any interaction count? Some interpretations suggest that consciousness itself plays a role in determining physical reality. This has led to famous thought experiments like Schrodinger's cat, and to interpretations like the von Neumann-Wigner interpretation, which posits that consciousness is necessary for the collapse of the quantum wave function. If the very structure of reality depends on observation, and if observation depends on consciousness, then maybe the universe requires consciousness to exist at all. Or maybe it is already conscious, constantly observing itself. The universe as a neural network. What if the universe works like a brain? Some physicists and computer scientists have noticed striking similarities between the structure of the observable universe and the neural networks in our brains. For example, a 2020 study found that the cosmic web, the vast network of galaxies and dark matter, resembles the layout of neurons and synapses in the brain. The density, distribution, and connections between nodes show similar patterns. This has led to speculation that the universe could be a kind of giant information processor. Some theories, like those proposed by theoretical physicist Max Tegmark, suggest that reality is mathematics and perhaps computation. Could the universe be thinking? Could we be neurons in a cosmic mind? The anthropic principle and cosmic fine-tuning. Why is the universe so perfectly tuned for life? The anthropic principle states that the universe appears fine-tuned for conscious observers. The fundamental constants gravity, electromagnetism, the strong and weak nuclear forces seem set just right to allow life to exist. If any of these values were even slightly different, stars wouldn't form, planets wouldn't exist. Life, as we know it, would be impossible. Some see this as evidence of design. Others propose a multiverse, an infinite number of universes with varying parameters. We happen to live in the one where consciousness is possible. But there's another possibility. Maybe consciousness is not a result of the universe, but a requirement for it. Maybe the universe is structured in such a way because it is, on some level, conscious. Consciousness as a field. What if consciousness is not confined to brains, but is a field, like gravity or electromagnetism? This idea is gaining popularity in certain circles. Just as particles interact with the electromagnetic field, maybe all things interact with a consciousness field. Some propose that this field permeates the universe, and that complex systems like brains can tune into it. This might explain why consciousness feels so unified, despite the billions of neurons involved. If this is true, then consciousness is not produced by the brain, but received or filtered by it. This would mean consciousness is everywhere and always has been. The Gaia hypothesis and global mind. Looking closer to home, the Earth itself may be conscious. The Gaia hypothesis, proposed by James Lovelock, suggests that Earth functions as a single living organism, self-regulating and adaptive. Others have extended this idea into the realm of mind, suggesting that human civilization, technology, and communication networks form a kind of planetary brain. Could the internet be the early nervous system of a global mind? Could the Earth itself be awakening? And if that's true for one planet, what about the universe as a whole? The universe awakens. Let's take the leap. If the universe is conscious, what does that mean for us? Are we fragments of its awareness, individual eyes through which it sees itself? Are we co-creators of reality? Or are we just beginning to glimpse a truth too vast to comprehend? Maybe consciousness didn't arise within the universe. Maybe the universe arose within consciousness. This flips the script of science and spirituality. It suggests that consciousness is not the end product of evolution, but the beginning of existence itself. The mystery remains. We may never know for sure whether the universe is conscious, but by asking the question, we touch something profound. In exploring the cosmos, we are also exploring ourselves. The boundary between observer and observed blurs. Perhaps the ultimate discovery is that there is no boundary at all. You are not just in the universe, you are the universe becoming aware of itself. And that changes everything. Into the nothing. Imagine no space, no time, no light, no matter. Nothing. Not emptiness, not a vacuum, not darkness, but the complete absence of existence. Yet somehow from that came everything. The stars, the galaxies, the laws of physics, even your thoughts right now. How is it possible that something as complex and ordered as our universe could come from nothing? This isn't just a philosophical question. It's a scientific one. And at the front lines of that question is quantum physics, a framework so strange, it makes nothing one of the most complicated ideas in all of science. In this journey, we'll explore what physicists mean by nothing, how quantum fluctuations can create particles from an empty space, whether the universe emerged from a quantum void, and why this question reshapes our understanding of existence itself. Let's fall into the void, redefining nothing. In everyday language, nothing is simple. It's the absence of stuff. An empty cup, a blank page, but in physics, especially quantum physics, nothing is far from empty, even what we consider a vacuum, a region with no particles, no radiation, no atoms, is seething with activity. Welcome to quantum vacuum. Here, virtual particles constantly appear and vanish. Space is filled with fields, Higgs fields, electromagnetic fields, gravitational fields, all fluctuating at quantum levels. At absolute zero, when thermal motion stops, quantum motion continues. Why? Because of the Heisenberg uncertainty principle. You can't simultaneously know the exact energy and position of a system, so even nothing must wiggle. This quantum jitter isn't just theoretical, it's measurable. It's the reason for the Casimir effect, where two uncharged plates in a vacuum attract each other thanks to fluctuations in the vacuum energy. So, the first lesson: nothing is not nothing. It's a dynamic stage buzzing with potential. Virtual particles and the birth of matter. Inside this energetic vacuum, virtual particles constantly pop in and out of existence. These aren't particles in the traditional sense. They don't follow the rules of real particles. They're fleeting disturbances in quantum fields, allowed to exist only briefly due to energy-time uncertainty. Sometimes these pairs annihilate instantly, but under the right conditions, like near a black hole's event horizon, one particle can fall in while the other escapes. This process, proposed by Stephen Hawking, leads to Hawking radiation black holes slowly evaporating over time. It proves that quantum effects at the edge of nothingness can generate real, observable consequences. If that can happen near a black hole, could it happen on a universal scale? Could the universe emerge from nothing? Here's where things get wild. Some cosmologists propose that the universe itself could have emerged from a quantum fluctuation, a spontaneous blip in the vacuum energy of a quantum field. Lawrence Krauss famously wrote, "A universe from nothing suggesting that if you have quantum laws and gravity, you don't need a creator, you just need instability in the void. But critics argue, laws themselves are something. So where did they come from? Others, like Stephen Hawking and James Hartle, suggest that the universe had no boundary. It didn't begin in time, but emerged as a closed, self-contained system. Inflationary cosmology takes this further. Tiny fluctuations in the early universe expanded exponentially, creating the structured cosmos we see today. So perhaps nothing isn't a clean slate, it's a bubbling cauldron of potential. Nothing, multiverse, and the anthropic principle. If something can come from nothing once, could it happen again? Welcome to the multiverse. Some theories suggest that our universe is just one of many, each popping into existence from quantum fluctuations in a meta-reality. Each universe could have different laws, constants, or dimensions. The anthropic principle says we find ourselves in this universe because it's one of the few where life is possible. In most, conditions wouldn't allow galaxies, planets, or consciousness. It's a controversial idea. Some see it as giving up on deeper explanations. Others see it as the only way to make sense of the fine-tuning of our universe. Is nothing the seedbed of infinite universes? Or is the multiverse just a placeholder for what we don't yet understand? The psychology of nothingness. We're hardwired to think in terms of things. So when science tells us that the fabric of reality may emerge from non-being, it challenges not just our physics, but our intuition. Ancient philosophers grappled with the void. In modern times, Nietzsche, Heidegger, Sartre, they all asked what it means to exist at all. Quantum physics now brings those questions into measurable reality. Maybe consciousness itself is a byproduct of quantum complexity arising from the vacuum. Maybe the brain is a fluctuation in space-time. Dreaming it exists, maybe the universe is not a thing, but a question unfolding. What we know and still don't. We've detected vacuum energy. We've measured virtual particles. We've modeled quantum cosmology, but we still don't have a complete theory of quantum gravity. We don't know how time really began. We don't know what underlies the fields themselves. The Planck scale 1035 meters is where quantum mechanics and general relativity crash. It's where our current tools break. To understand true nothingness, we may need a new paradigm, string theory, loop quantum gravity, emergent spacetime, or something yet unimagined. Until then, we circle the void knowing it's not empty, just waiting. Until then, we circle the void knowing it's not empty, just waiting. The power of nothing. The greatest mystery of the universe may be that it shouldn't exist at all, but it does, and maybe, just maybe, it came from nothing. But not the kind of nothing you imagine, not silence or darkness, but a seething, quantum field of uncertainty, ready to erupt into stars, atoms, and life. So next time you stare into the night sky, remember, the stars might not be the greatest miracle, the nothing between them might be. Like this journey into the void, subscribe, share, and join us as we keep asking the biggest questions in the universe. What if everything is an illusion? Close your eyes. Imagine standing in front of a vast wall perfectly black, smooth, and infinite. You reach out your hand, but instead of touching substance, it dissolves into light. Nothing is solid. Nothing is fixed. What if everything, your body, your memories, even space and time, isn't as real as it seems? What if the universe itself is a projection? This isn't science fiction. It's one of the boldest, most mind-bending ideas in theoretical physics today, the holographic principle. The suggestion that our entire 3D universe might be a shadow, a projection of information encoded on a distant 2D surface. In this documentary, we'll journey into black holes, quantum information, string theory, and the boundaries of space and time to uncover whether reality is truly holographic. The origin of a radical idea. In the 1970s, a Dutch physicist named Gerard T. Hooft was studying black holes and quantum gravity when he made an astonishing proposal. What if all the information contained in a region of space could be described by information on its boundary? Later, the idea was expanded by Leonard Susskind, who connected it to string theory. Susskind argued that just as a hologram stores a 3D image in a 2D format, so too could the universe store all its physical information on a 2D surface, and yet create the illusion of 3D reality. They weren't alone. The proposal was deeply rooted in attempts to solve one of the greatest paradoxes in physics, the black hole information paradox. Black holes, according to general relativity, seem to destroy everything that falls into them, including information. But in quantum mechanics, information can't be destroyed. Something had to give. The solution? Information may never really be lost inside a black hole, because it could be encoded on its surface. That's where the holographic principle was born. Black holes and the edge of reality. Black holes are not just cosmic monsters. They are laboratories of reality. In 1974, Stephen Hawking shocked the world by showing that black holes are not completely black. They emit radiation now known as Hawking radiation due to quantum effects near the event horizon. Over time, this radiation can cause the black hole to vaporize. But if the black hole disappears, what happens to the information about the matter that went into it? If it disappears completely, it violates quantum theory. If it persists, where is it stored? Hawking, Susskind, and others argued vehemently. A solution began to emerge. Information about what falls into a black hole is stored not in its interior, but on the event horizon, the two-dimensional surface. This led to an incredible realization. Perhaps the entire universe works the same way. Just as a black hole encodes its contents on its surface, the cosmos may be the same. The mathematics of holography. In 1997, physicist Juan Maldacena made a stunning breakthrough. He proposed a duality between two radically different theories. Gravity theory in 5D spacetime including our usual dimensions, quantum field theory without gravity at the 4D boundary of this space. This became known as the ADS or CF correspondence, an exact mathematical realization of the holographic principle, although the particular geometry anti-de Sitter space does not describe our universe. The universe as information. At the heart of the holographic principle is one strange idea. Information is more fundamental than matter. Everything we see around us may be the result of bits, tiny units of quantum information interacting, processing, and evolving. This isn't just theory. Scientists like Seth Lloyd and John Archibald Wheeler have proposed that the universe is fundamentally a quantum computer processing information at the smallest scales. Wheeler's famous phrase, "it from bit," suggests that every particle, every field, and every interaction arises from binary yes-no choices from logic, not substance. Your body, your thoughts, the sun, the galaxies all might be emergent phenomena built from pure information, unfolding on a lower dimensional surface. Could we ever prove it? If the holographic principle is true, can we test it? Physicists are trying. Some look at cosmic microwave background data, searching for statistical fingerprints of a holographic geometry. Others examine quantum entanglement and the structure of spacetime itself. Experiments like the Fermilab holometer aim to detect holographic noise, tiny jitters in spacetime that might reveal its digital nature far. No conclusive evidence, but hints keep coming. Theories involving emergent gravity, tensor networks, and quantum error correction are painting a picture of spacetime as an illusion, built from deeper rules. If true, it would mean that you are not truly in space, but rather, your entire reality is a projection from a distant, invisible boundary. Consciousness and the hologram. Some thinkers go even further. Could consciousness itself be a holographic phenomenon? Neuroscientist Carl Pribram and physicist David Bohm suggested that the brain doesn't store information like a computer, but like a hologram, distributed, overlapping, resilient. Perhaps reality and mind are both projections, not separate, but reflections of deeper structures. Quantum consciousness remains speculative, but one thing is clear. The holographic principle forces us to rethink what we mean by real. Maybe the boundary between mind and universe is itself an illusion. What does it all mean? If the holographic universe is real, space is not what we think it is. Time may be an emergent illusion. Our world is deeply connected to an invisible boundary we cannot see. This isn't just theory. It's a call to rethink physics, philosophy, and perception itself. We may live inside a cosmic illusion, but that illusion is governed by rules we're beginning to decode. We are shadows of code. Awakening. The wall and the light. Remember that wall of blackness at the beginning? Maybe it's real. Maybe we're seeing its projection. Maybe we've spent millennia staring at the shadows on the wall, unaware that reality lies not within the cave, but on the wall itself. The holographic principle doesn't diminish the universe. It reveals how much more there is to understand, and perhaps how deeply we are already a part of it. If you found this journey fascinating, subscribe for more mind-expanding cosmic explorations. Are we truly alone? Or are we just not listening carefully enough? Are we alone in the universe? Part 1: A planet under suspicion. 124 light-years from Earth. There is a planet unlike anything in our solar system. It's called K218b, 2.5 times the size of Earth, with a massive ocean, hidden beneath a thick hydrogen-rich atmosphere. And now, scientists have found something. In that atmosphere, a chemical fingerprint, one that on Earth is only produced by living organisms. Part 2. James Webb. A look through the universe. The James Webb Space Telescope is not just a camera, it's a machine that analyzes light from other worlds. It studied the atmosphere of K2-18b. Not by flying there, but by watching starlight, passing through the planet's gassy shell. And in that light were traces of something unexpected. A molecular signal. That, on Earth, usually means life. Part 3. Molecules and Excitement. Scientists detected traces of dimethyl sulfide on Earth. This molecule is produced by marine life, like plankton, but is it really a sign of life on another planet? No one knows for sure, even with perfect data. It could still be from something geological. Still, it's the strongest evidence of possible life we've ever seen. Part 4. We've been here before. This isn't the first time we've seen hints of life. On Mars, we thought we found microbes, but it turned out to be just chemistry on Europa, beneath layers of ice. There's an ocean that could be alive. Enceladus has geysers spraying something strange into space. Over and over again, we find clues, hints, promises, but never a clear answer. Not yet. Part V. Our position. It's easy to get excited. Headlines love words like alien life and discovery, but science doesn't work that way. It's not about hype, it's about evidence. This isn't a press release, it's a process. Careful, slow, and right now, we have something interesting, but not something certain, not yet. Part 6. What if it's true? What if we're right? What if this molecule really does mean life? Then it wouldn't just be a discovery. It would be a revolution. We wouldn't be the center of biology anymore. We'd just be one of many strange stories, scattered across the stars. If life formed out there, it means life isn't rare. It means life is the rule, not the exception. It could be swimming through alien oceans, growing under different suns, dreaming maybe. Like we do. It would mean the universe is not empty. It's alive, and we are not alone. Part 7. What comes next? Scientists will keep watching. The James Webb Telescope will collect more data, more light, more clues. We'll scan the skies for more planets like K2-18b, worlds with oceans, with air, with potential. Other telescopes are coming too. Missions planned for the icy moons of Jupiter and Saturn, Europa. Enceladus. Titan because sometimes the answers might be closer than we think. The search is just beginning. What is life? What do we even mean by life? Must it breathe, think, reproduce? Does it need DNA? Or just complexity and persistence? On Earth, life is made of carbon and water, but maybe out there, it's made of something else. Maybe it doesn't walk. Maybe it floats. Maybe it doesn't care that we exist. Maybe it's been there for billions of years, waiting. Conclusion. What it all means. Maybe we've found something, maybe not, but this isn't about aliens. It's about how far we've come. And how much we still don't know, the fact that we can analyze the air of a planet 124 light years away. That's incredible. IT means science isn't. IT means wonder is still possible. We may be alone, or we may not be, but we're asking the right questions, and we're finally learning how to listen for the answers. Our take, honestly. We don't make bold claims. We're not saying aliens are real, but we're also not saying it's nothing. We believe in data, in patience, in science. And what's happening right now, this slow process of watching, thinking, questioning, that is the discovery. Maybe there's life out there, maybe not. But either way, asking the question still matters, because when we ask, we grow, we reach. We remember that we're part of something way bigger than ourselves. If you've made it this far, you're probably one of the few who actually care. So thank you, and if this spoke to you, subscribe. We're just getting started. Right now, you're moving. Even if you're sitting perfectly still, your body is riding on the surface of a planet spinning at about 1,670 kilometers per hour, 1,037 miles per hour at the equator. That's faster than a bullet. And yet, you feel nothing. But what if, in an instant, that spin stopped? Not gradually, not with warning, just stop. It sounds like science fiction, but let's explore what would happen if the rotation of Earth suddenly came to a halt. It would be catastrophic, terrifying, beautiful, and a brutal reminder that we're riding on a fragile miracle. Moment zero, the instant stop. Let's imagine this moment like a thought experiment. Earth's rotation halts instantly. Not the orbit around the sun, just the daily rotation. The 24-hour spin that gives us day and night. What happens? In one word, inertia. The atmosphere, the oceans, every car, building, and human on the surface, all of it is still moving at 1,670 kilometers per hour. The crust might stop, but the air and water don't. A global wind of unimaginable force tears across the surface. Skyscrapers collapse. Entire forests are flattened. Anything not anchored to bedrock is thrown. You wouldn't just fall over. You'd fly. Buildings would shred. Cities would vaporize in wind-driven fire. This is not exaggeration. It's physics. Oceans turn into walls. Now, let's talk water. The oceans don't stop moving just because the land does. At the equator, they surge forward, forming a super tsunami that dwarfs anything humanity has ever seen. Imagine walls of water hundreds of meters high rushing across continents. The Atlantic floods Europe. The Pacific devours Asia. Inland cities are no safer rivers reverse. Lakes surge out of their beds, and coastlines vanish. The oceans obey Newton, not mercy. Earth's shape starts to shift. Earth isn't perfectly round. It bulges at the equator because of its rotation. But no spin equals no bulge. Over time, the planet would begin to reshape itself into a more perfect sphere. This would cause tectonic chaos, earthquakes, volcanoes, mountain ranges collapsing, new ones rising. Places that were sea level would become mountains. Mountains could become valleys. Continents might even shift faster, not over millions of years, but in decades. Gravity gets weird. At the equator, the centrifugal force from Earth's spin slightly counteracts gravity. If the spin stops, gravity increases there. Not enough to crush you, but enough that you'd feel it. You'd weigh slightly more, jump lower, fall faster. Meanwhile, poles would experience minimal change, but sea levels there would rise as water redistributes. Ice sheets in Antarctica might grow, while areas near the equator would flood permanently. Goodbye, magnetic field. Earth's magnetic field is generated by the motion of molten iron in its outer core, and that motion is influenced by the planet's rotation. Without spin, the dynamo effect weakens or stops. The magnetic field collapses. And with it, our protection from cosmic radiation and solar wind. Satellites die. Power grids fry. Radiation levels on Earth's surface spike. Life as we know it, in danger. A day lasts a year. Without rotation, Earth would no longer have a 24-hour cycle. One side would face the sun for 6 months. The other, total darkness. The day side would make deserts expand, oceans evaporate, heat becomes lethal. The night side would freeze, temperatures plummet to 100 C or lower. Oceans begin to freeze solid, and photosynthesis stops. Twilight zones near the terminator line might remain habitable for a while. But humanity would be on the move, fleeing heat and ice, chasing survival like migratory birds. The sky goes mad. Forget what you know about sunrise and sunset. Without rotation, there would be no daybreak. The sun would hang in the sky, and moving, slowly tracking overhead across months. Timekeeping would collapse. Clocks meaningless, calendars useless. The stars would only shift with Earth's orbit, constellations would crawl, not spin. The northern and southern skies would no longer turn, Polaris would be frozen in place. Astronomy would become alien. The sky would be a strange, unfamiliar dome. Weather and climate collapse. Earth's rotation drives winds, weather patterns, and ocean currents through the Coriolis effect. Without spin, that system breaks. Jet streams vanish. Hurricanes become impossible. But where's heat distribution across the planet stops? The tropics overheat. Poles freeze harder. Deserts spread. Rainforests dry up. Agriculture fails. Seasons become meaningless. Droughts and floods appear randomly. Climate itself collapses. Life tries to adapt. Some species might survive in the twilight zones, areas between permanent day and night. Mosses, extremophiles, bacteria they might hang on. Humans, maybe in bunkers or artificial habitats. But we'd lose everything we know. Farming as we know it, gone. Global trade, collapsed internet, satellite systems dead, civilization scattered, nomadic, desperate. We'd have to become a new species built to live on a planet that no longer spins. Could it actually happen? So, could the Earth actually stop spinning? Short answer, not likely. The forces required are astronomical, literally. Maybe if another massive object collided with us. Or in billions of years, tidal locking might gradually slow the spin until Earth only shows one face to the sun like the moon does to us. But it wouldn't be sudden. Still, the fact that something so simple, stopping rotation, could destroy us, that's worth thinking about. Fragile miracle. We live on a planet delicately balanced, spinning, tilted, orbiting just right. We take it for granted, but Earth's rotation is not just a cosmic clock. It's our shield, our climate machine, our rhythm, our safety. Without it, we are lost. In the silence of stillness, the Earth screams. So next time you feel like nothing's happening, remember, the only reason you're still alive is because the world hasn't stopped.